Welcome to the video tutorial series of SIMPOW. In this video, we will guide you through an exercise on how to perform static fault analysis in SIMPOW using STAPOW. STAPOW is a tool for performing static fault analysis for both symmetrical and unsymmetrical conditions. The result of the simulation is currents and voltages in the system at a specified time instant. STAPOW can use two calculation methods, a standard method named normal calculation, as well as the standardized IEC 909 method. Let us start with task 1. STAPOW requires three input files, the OptPow results file, the DINPOW file, and a so-called STAPOW file. The STAPOW file describes the different faults and cases which are to be analyzed, and we will begin by creating one. We open up the current working directory, create a new file which we name kurs.stapow and open it in a text editor. First, we want to define a fault. This is done in the data group faults. We name the fault F1. It should occur at bus 7 and be a three-phase to ground fault. Next, we want to add a case which should include the fault we just created. This is done in the data group cases. We add a case named 1 and it should include the fault F1. The parameter NF equals the number of faults included in the case, so we set it to 1. The parameter SWS1 should equal 2, since we want to display both sequence and phase quantities in the results. We save the file and close it, concluding task 1. In task 2, we are to perform the STAPOW simulation. First, we start SIMPOW and set the working directory if it is not already done. Next, start STAPOW by clicking on Fault Computation and Base Run STAPOW. Load the OptPow result file from previous OptPow runs, the DINPOW file as well as the newly created STAPOW file. Under Miscellaneous, select Normal Calculation. Run the simulation by clicking on File, Go. STAPOW performs the simulation and outputs a result file named stapow.kurs. This concludes task 2. In task 3, we are to analyze the results file from STAPOW. Go to the working directory and open the result files in the text editor. This is how a STAPOW results file looks like. By scrolling down, we can find case 1. Here we can see the results in both sequence and phase quantities. Currents and voltages associated with the bus at which the fault was connected are shown here. We can, for example, see that the fault current is about 7.6 kA. This concludes task 3. In task 4, we will add more faults and create more cases in the STAPOW file. We open the STAPOW file and add 2 new faults according to the exercise sheet. Next, we add 2 new cases, also according to the exercise sheet. We save and close the STAPOW file and return to SIMPOW. STAYPOW will now run one simulation for each case, which is defined in the STAYPOW file, and present it in the results file. Run the simulation again and open the results file. We can now see that the results file contains one set of results for each case, both in sequence and phase quantities. For case 2, the positive sequence short circuit impedance for fault F1 can be found here. For case 3, the fault current for fault F3 is about 5.2 kA. This concludes this video tutorial. Thank you for watching this video.